The Tunguska Event. New evidence and the shocking bouncing asteroid theory. On June 30, 1908, a remote corner of Siberia was rocked by an explosion 1,000 times more powerful than Hiroshima. 80 million trees were flattened across an area the size of London, yet no crater was found, no fragments. What truly happened in Tunguska? And what if we've been missing the most incredible explanation of all? Welcome back to the curious past, where we delve into history's most perplexing enigma. Today, we're revisiting one of the greatest unsolved mysteries of all time, the Tunguska Event. For over a century, scientists and enthusiasts alike have grappled with its perplexing details. But what if new evidence, combined with a groundbreaking theory, is about to rewrite everything we thought we knew? Join us as we uncover the latest insights and explore a shocking new hypothesis that could change our understanding of this cosmic puzzle. Let's set the scene. The date was June 30, 1908. In the early morning, residents across a vast region of Siberia witnessed a blinding flash of light, followed by a colossal explosion. The shockwave was felt hundreds of miles away, registering on seismographs across Europe. In the immediate vicinity, an area of over 2,000 square kilometers, roughly equivalent to the size of a major metropolitan area like London, was utterly devastated. Trees were felled radially outwards from a central point, yet remarkably, there were no reported human casualties in the sparsely populated region, and crucially, no impact crater. Early Soviet expeditions, notably Leonid Kulik's in the 1920s and 30s, were met with baffling findings. They expected to find a massive crater and meteorite fragments, but instead they found a vast expanse of flattened trees and a peculiar absence of any definitive impact site. This lack of a crater, coupled with the absence of large meteorite fragments, became the central enigma of Tunguska. For decades, the prevailing scientific theory pointed to a meteor or comet. The idea was that a celestial body, likely stony or icy, entered Earth's atmosphere and exploded in the air before hitting the ground. This airburst hypothesis could explain the radial felling of trees and the lack of a crater. However, the complete absence of any significant fragments remained a sticking point. Other, more exotic theories, ranging from mini black holes to antimatter explosions or even extraterrestrial spacecraft, have been proposed over the years. But these largely lack scientific backing and often stray into the realm of pure speculation. Fast forward to the 21st century. With advancements in technology and scientific analysis, researchers have been able to re-examine old data and uncover new clues, deepening the mystery while simultaneously bringing us closer to a potential answer. One significant discovery involves microscopic spheres. These tiny, glassy or metallic spheres, found embedded in the soil and peat layers at the Tunguska site, bear the chemical signatures of extraterrestrial origin. Their presence strongly suggests that whatever caused the explosion came from space, and that some material, however minute, did indeed reach the ground. Then there's the intriguing case of Lake Checo. For years, some scientists have theorized that this small, circular lake, located near the epicenter of the blast, could be a hidden impact crater. Its conical shape and the presence of unusual sediments at its bottom fueled this hypothesis. However, recent studies, including seismic surveys, have largely debunked this idea, suggesting Lake Checo is a natural formation much older than the 1908 event. This means the mystery of the missing crater persists. Further insights have come from dendrochronology, the study of tree rings. Scientists have analyzed the growth patterns of trees in the blast zone, revealing precise details about the explosion's intensity and direction. The radial felling pattern, combined with the scorched trunks of trees at the epicenter that remained standing, points to a powerful airburst. The growth anomalies in the years following 1908 also indicate a significant environmental disturbance. Perhaps one of the most compelling pieces of indirect evidence comes from ice cores extracted from Antarctica. These ancient ice layers act as historical archives, trapping atmospheric particles and gases from centuries past. Researchers have found elevated levels of certain elements, consistent with an extraterrestrial impact event, in ice layers corresponding to the year 1908. This global signature suggests that the Tunguska event was not just a local phenomenon, but had a measurable impact on Earth's atmosphere, hinting at a larger, more complex interaction than previously imagined. For over a century, the absence of a crater and large fragments has been the Achilles heel of the meteor theory. But what if the object didn't just explode in the air? What if it bounced? This is the essence of the groundbreaking grazing asteroid or bouncing asteroid theory, a hypothesis gaining traction among some researchers. The theory suggests that the Tunguska object was not a comet or a fragile stony meteor that disintegrated completely, but rather a denser, iron-rich asteroid. Instead of directly impacting or fully airbursting within the atmosphere, this asteroid entered Earth's atmosphere at a very shallow angle, skimmed the upper layers, and then, due to its high velocity and the atmospheric pressure, effectively bounced back out into space. Imagine a stone skipping across water, but on a cosmic scale. As the asteroid grazed the atmosphere, it would have experienced immense friction and pressure, causing it to heat up rapidly and shed material. This superheated material would then have caused the massive airburst we know as the Tunguska event. The main body of the asteroid, however, would have continued its journey, escaping Earth's gravitational pull and disappearing back into the cosmos. Computer simulations and advanced modeling have shown that such a scenario is indeed physically possible. The trajectory and velocity required for a grazing event align with the observed damage pattern at Tunguska. Furthermore, this theory elegantly explains the lack of a crater, because the main body never actually hit the ground. It also accounts for the microscopic extraterrestrial spherules found at the site. These would be the tiny fragments shed by the asteroid during its atmospheric encounter. This theory has profound implications. It suggests that humanity was far closer to a catastrophic impact than previously understood. Had the asteroid entered at a slightly steeper angle or been slightly less resilient, the outcome could have been devastating, potentially wiping out a major city. It's a chilling reminder of the constant cosmic dance happening around us and the fine line between a near miss and a global catastrophe. Why the mystery persists. Despite the compelling nature of the bouncing asteroid theory and the wealth of new evidence, the Tunguska event remains an official unsolved mystery, because definitive proof, such as the recovery of a large fragment of the original object, has yet to materialize. The remote and challenging environment of the Tunguska region makes extensive fieldwork incredibly difficult, and the sheer scale of the event means that any remaining evidence is likely dispersed and microscopic. Furthermore, the scientific community is inherently cautious. While simulations show the grazing scenario is plausible, proving it conclusively requires more than just theoretical models. It demands tangible, undeniable evidence that directly links the event to such a phenomenon. Open questions still linger. What was the exact composition of the object? What was its precise trajectory? And could there be other, as yet undiscovered, explanations? Researchers continue to explore the site, analyze historical data, and refine their models. The quest for answers is driven by both scientific curiosity and the practical need to understand potential threats from space. Will we ever get a definitive answer? Perhaps, as technology advances and our understanding of cosmic phenomena deepens. the secrets of Tunguska may one day be fully revealed. But for now, it stands as a powerful testament to the universe's unpredictable nature and humanity's enduring fascination with the unknown. The Tunguska Event, with its new layers of evidence, and the intriguing bouncing asteroid theory, reminds us how little we truly know about the cosmos and the potential threats that lurk out there. Perhaps the greatest mysteries are not those that are unsolved, but those that we have yet to fully comprehend. What are your thoughts on the Tunguska Event and the bouncing asteroid theory? Do you believe it's the most plausible explanation, or do you have another theory? Share your thoughts in the comments below. If you found this journey into the past fascinating, please give this video a like. Subscribe to The Curious Past for more deep dives into history's enigmas, and check out our other videos on cosmic mysteries and unexplained phenomena. Until next time, keep questioning, keep exploring, and stay curious.